We're going to bring you on a brief journey into penetration testing. We're going to briefly talk about why we do penetration tests, how we do it, and the main focus during this presentation is going to be basically how we do it. And we're going to bring you a real-world example of a pen test and a real attack scenario. What this is not the how to break into companies. So please don't bring these things with you. Go back home and use these techniques to break into companies.
We frown upon this.
Sorry?
We frown upon this.
Yeah. Don't bring that to us. So we start off with why we do penetration testing. So if we go back in not really in the history, but if we go back in the earliest years here, we could read about a lot of companies being hacked. So for instance, I don't know if you know about Target. Target is a big merchant in the US who lost 40 million credit card numbers in an attack. We have Neiman Marcus, 1.1 million credit card got lost. Everybody knows about Yahoo, I hope. Yahoo lost 3 billion user accounts, got leaked out on the internet. And most recently, we had the Equifax data breach, where 143 million customer accounts got leaked with social security numbers, full addresses, and everything. And it just adds up. We have more and more companies being attacked. And as you can see here, they're very large companies. When we see a lot of them, you think about that they should have some kind of security, of course. But what is common with those ones, as I said, they all got hacked. So one big driver points for performing penetration tests is, of course, to prevent, or us helping you guys prevent being hacked. Then we have other factors as well, as compliance and regulations. We have HIPAA, we have PCI DSS. Anybody knows about GDPR? Yeah. So for us two here, or for SecureLink, we work a lot with companies who have the compliance or the PCI compliance. Anybody knows about PCI? It's basically Visa, MasterCard who puts a lot of regulation towards merchants or other ones who process credit card information. So one of the demands that they have is that the companies need to perform penetration tests in their card data environment. And then we have the GDPR, or the General Data Protection Regulation, which is basically there for protecting your personal data. So if you're a company storing personal data, that will hit you. I think we're talking about if you have personal data being hacked and you lose personal information, you can get a fine on 4% on your total company revenue, or up to 20 million euro. I think that's a good driver point to up on the security field. So there's a lot of why, of course, you should do penetration tests or work with security within your company. So now we're going to talk about how we do it. And when we perform penetration testing, we follow a very common pen test methodology where basically it starts with information gathering, threat modeling, vulnerability analysis, exploitation, post-exploitation, and of course the most important one, the reporting phase.
Now, if we're going to have a look at information gathering, what is information gathering exactly? Well, you have a meeting with your client, right? You define your scope, you talk to them, you understand what's the necessity. We define which web servers we're going to test, which web applications, so on and so forth. The point here is that we like to have a white box approach because unlike an actual attacker, we have a limited time. So for us and for you, it's much better to have as much information as possible. So when we go in, we know as much as we can. Now, of course, information gathering doesn't just stop at, yeah, we have a meeting with the client and that's it. We also have different search engines. We Google the company, some cases the employees, so on and so forth. Now, after you've done your, for example, scans, so on and so forth, then we switch to threat model. We start to compile all that data and you want to have a look at, okay, how should I proceed? So then you find your vulnerability, which you think that you're going to exploit, and we're going to go for the vulnerability analysis. So you prepare your attack, you launch it, and then we go for the exploitation.
So, exploitation, the fun stuff. Just as Danut we're talking about here, so when we do penetration testing, it's a lot different of being a real attacker, of course. Because sometimes we have a full environment. Basically, you will be outside on the internet trying to get access to our company, and you have any way you want to doing it. But most often we have very, very limited scopes. So in that case, the exploitation phase would be basically be, okay, we take over one machine, then we try to escalate our privileges, and we try to get access to other machines within that specific scope. For the demonstration purpose, what we will demonstrate is basically a full attack from internet going into a company and take that company over. And then, of course, we have the reporting phase, which is very, very crucial for us as a pen tester and for you who order the pen test. So in the report, what we're doing, we have, of course, an executive summary describing what we have done, general recommendations, the findings that we have found. We describe every entity that we have tested, each and every findings that we did find. There is a specific description of that vulnerability, and the remedy, how to solve the issue, trying to help you to get more secure in the long run. But as I said, the main focus of this presentation is going to be how we do it. So for the demo, we have created a small company called Acme. So in the demo, we're going to be the evil attacker outside on the internet. We will go through internet, and here, I hope I don't, sorry. We will try to, from internet, take over a machine on a DM set environment. There's going to be a web application or a web server with WebLogic on it. Then we, from the DM set, we're going to pivot into the internal network and take over the client server and in the end, hopefully, the domain controller. But before we start, we always start with information gathering.
So as I said, information gathering. You have other things other than just talking with the client. So we have a lot of search engines. We have Shodan, we have Google, we have Nmap for your port scan. And you also have dumpster diving, which I don't really recommend, but it's there.
Don't forget, don't forget RTFM.
Yeah.
That's a good
important thing. RTFM, right? So read the manual and understand it. Now, what we're gonna do is we're gonna start out with a small Shodan search. Now, Shodan is kind of like a Google for hackers. So we search companies, we search services, and it's gonna bring up and display what's available online. So we can see here that just a simple search on WebLogic displays 48 targets. Now, let's assume that our company, Acme, is one of these targets. So what we're going to do is, okay, so it runs WebLogic, so we're going to switch over to, let's see what's open. So what we're going to do is, we're going to run a TCP port scan with Nmap. Now, this is available online, for example. Anyone can access it. Anyone can basically just enter an IP over there or a host name and launch a scan towards the target. What's important here to know is after we've done our Shodan and we've done a cloud Nmap over here, we still have not touched us as attackers. We have not yet touched the server. So if we're gonna have a look, it's just normal traffic, right? I mean, Shodan is just normal querying, then we have TCP scanning, but it's still not us touching the web server. So here we can see that all of our interactions are still from us, the hackers, to the web. Now, to put this in practice and to show you guys how exactly this would look, we have a small demo. So we're not going to run Nmap from a website. We're going to run Nmap locally so you guys can have a better understanding.
And since there is so many steps here, we're not going to do it live. We actually pre-recorded the videos. And I'm really glad today that we did that because there is so many things.
It's always fun to read presentations. Right, so the attacker's view. What we're gonna do here is we're gonna try and see if our target, the WebLogic server, is up. So we're gonna ping it. Let's see. So we know it's up. Perfect. Now I want to know what's open on that service. So we do a very quick nmap and see which ports are available. So we launch our nmap scan, and we can see here we have an SSH port open and 7001, which is a WebLogic administrative port. Now, WebLogic, some versions suffer from what is known as a Java unsafe visualization remote code execution. Long word. But that relies on the fact that there's an outdated Apache Commons Collection library which is vulnerable to deserialize an attacker's trusted input. So we have a script here which will allow us to execute the payload. So first we need to check if it's vulnerable, right? So we have a filter. We're going to check for ICMP packages on our machine, and we're going to launch the script, WebLogic Python, point it towards the target machine running WebLogic on the administrative port using serial, which is a commonly available tool for generating payloads. And in the end, we're going to make the target machine try to ping us. So we launch the script, and in just a couple of seconds we can see that the target has started to ping us. What this means for us is that it's vulnerable to remote code execution. Perfect. Now, the next step would be, okay, so I have a vulnerable WebLogic machine, but I need to know more. I want to get a hold of that machine, right? So what I'm going to do is I'm going to see which users are available. A bit more reconnaissance. So it's wrote the same thing basically. So the idea is that we're gonna try to make the target machine show us which users are in the system. So we're gonna do kind of a similar thing as the ICMP filter. So we're not gonna make it ping us, but we're gonna make it connect to us with a message. So we're gonna set up a netcat listener, and we're gonna formulate the same WebLogic payload, but this time it's gonna be a little bit different. So what we're gonna do is we're gonna try to see what's in the home folder of the web server, take those contents and try to send it back to us, so we know which user is active. So I can see here we're doing an ls command, which is basically list the home folder and then make the target connect back to us using netcat. Now it's interesting that this netcat command is available on all netcat distributions, so you don't need any traditional ones. So we can see here that user Billy is within the system. Now Billy, very soon, is going to have a very bad day. So now that we know which user is running, what we're going to do is we're going to try to gain access as that user.
So just to wrap it up very quickly as well. As we said here before, initially we start out as an attacker out in the internet. Initially we didn't even touch the systems. We use online search engines and online functions trying to get information about the target system. Now we have initial contact with the web front end on the DMZ zone. And now we're going to go over to the exploitation phase, basically take over this machine residing in the DMZ.
So as you were saying, we're going to try to take over. Now the way we're going to try to take over in this case, we're not going to try to brute force any users, we're not going to try to raise red flags. So what we're going to do instead, we're going to formulate a small bash code which uses the same WebLogic payload, but this time we're going to inject our SSH key into the user's authorized key files, thus granting us access as that user. First, we're gonna set the execution mode on the script. And the next phase is to launch our bash script. We enter it, we send the payload. Now we're gonna check and see if we manage to inject it. You can see here, we're going to try to SSH as Billy, the user, into our remote host. There we go. And soon enough, we gain access as Billy on the system. You see here, it is our target. So it's perfect. Our initial foothold is done. We now have access to one of the servers. But you can't stop here, right? I mean, you have access as the user, but you want to go further. You want to go, into other zones. But before that, what you need to do is you need to gain higher privilege access. So what we're going to try to do is see if we can get root access. Awesome. Now, usually, WebLogic requires a higher privilege access in order to run. So you cannot run it as just any ordinary user. What you can do is you can configure it to run as an independent user, which is not root necessarily. But if you're going to take it out of the box and just run it for whatever reasons, you will need a root account. So going back to the idea about sending a message to our Netcat listener, we're going to check and see which user is the WebLogic web service running as. So instead of listing a home folder, I'm just going to check and see who am I exactly on the system. There we go. Connects back to me. And the payload is being sent now. Look, running as root. Awesome. So since we're running as root, how about we check and see the etc shadow file. Now the shadow file is basically the encrypted file for the user's password on a Unix system. So since we're root, we can display it, so we're going to send back to us the shadow file. Now we can see poor Billy's password. It's encrypted, but we're good. We're going to copy the hash and we're going to start cracking it. Now, for this case, we're just going to use a very simple tool. Anyway, now, still a copy pasting error. Right. So, we're going to use Jon, which is a CPU-based cracker. We're going to use a word list, which is available in almost all offensive security Unix distributions, called RockU. And we're going to apply the cracking with the word list on Billy's hash. And before you know it, there's Billy's password.
That's an awful bad password. Seriously.
I worked so hard
Danut.
on it. Work all day to get it.
That was really bad.
Sorry?
We will come to that, but it all depends, basically. Computing power and how complex and what kind of password hash we're talking about.
Yeah.
Long, complex password is always better, I would say. What we're doing now, we went from CPU-based password cracking to GPU-based password cracking. So it's basically how much money do you have to buy GPUs? And that goes fast.
Exactly.
That goes really fast.
So now we can see we're root on the system. So we're going to go and try to gain further access.
Oh, post-exploitation. That's what I like. So, another wrap-up here. Very quick. Once again, from internet, through internet, took over the WebLogic or web front-end server. So what we're going to do now, we're going to try to pivot through this machine and gain access to the internal network. So for this demonstration, what we're going to do, we're going to use a technique called LMNR and MBTNS poisoning. Anyone know what LMNR is? Anyone who works with IT in a Windows environment? LMNR and MBTNS is something they implemented from Windows Vista, basically. So we talk about a Windows environment, and we have clients and servers in a Windows environment. So we have an internal DNS system that responds back on requests. So I want to get access to a resource. For instance, the DNS responds back with the IP address to that specific resource. So, but in this case, the victim here, he wants to get access to SNEER1 share, might be misspelled, doesn't matter. Send a request to the DNS server, but the DNS server doesn't have any information about SNEER1. So what LMNR MBTNS does is basically the client broadcast out over the entire local subdomain and ask for this specific share. So since we're located, you remember the WebLogic server, it has an interface into the internal. In this case, it might be differently, of course. But it has an interface. So the only thing we're doing here, we're listening on the network traffic to see and search for those kind of requests. Because what happened is, DNS server sends back, I don't know anything about that resource. Client sends out the broadcast request, and me as an attacker, it's here at my place. I have it. So what happened is, victim sends his NTLM authentication hash back to me, and I respond back like, yeah, you can't access it, but I still have the authentication hash. So in reality, I'm going to show you how that actually works. So we're sniffing the traffic. We start the responder. And we can see down here that we start to get some connections. We have sent the poison answer to the client, which is on 10.1.100. And here we can see that from the domain, the user Nihu, which is actually Nisehult, he sent back his NTLM version 2 hash back to us. Which is very good, because now we have the password hash from that specific user, which is located in the domain. So what we could do is basically take the password hash and do exactly what Danut did before. Bring it to our password cracker and crack this specific password hash for the user. Get the clear text password and reuse it. But since we're attackers, we're extremely lazy. And that's what I like about it. So we're going to do a completely different thing here. So instead of just collecting the password hash, we will just listen to the traffic, and when it comes, we will just replay it to a machine which this user have access to. So what happens is, we see the authentication request, we take it, replay it somewhere else, and we get access. Fantastic. Let's see how that works. This goes really fast. Boom. We're in. So now we have command system prompt on the client machine that user have access to. What we're going to do now, this tool that we're using is prepared with a lot of different functions. So we're going to use a tool called Mimikatz, which we can load. And Mimikatz it's a real Swiss Army knife tool for us attackers. What it was basically created for is to read system memory. So in the memory, there's a lot of different spots where you can find pretty interesting information. So as we can see here, when we read the system memory on a specific spot, we can see that the user Nihu with a clear text password. And that's by listening on the traffic, take the authentication request, relay it somewhere else, get access, read the system memory, and here we have the clear text password. Yoo-hoo. Yeah, sorry, there's going to be some misspelling here, but bear with me. So next, since we have the we have the clear text password for that specific user, fire up remote desktop, misspelled, redo it again.
Part of the process.
Sorry, late nights. And then we get access to the client machine. So then we have like a full desktop access to a domain connected computer. And that's what we want, because now we are trusted in the network, basically. Connect, access, thank you. So, next step. So the next step here is going to be, already have that one, routed that box. We have access to the client. Now we want to go to this one and see if there are any interesting information. Because it's basically, when we do a penetration test, it's get the initial access to one computer. It doesn't really matter. Specifically on internal networks, you need that first access, because then you're trusted in the network, because it's a domain connected computer. Then you can start accessing and query the domain controller. And most often when you jump around between the different machines here with your access, you try to find information that could lead you to the next step. So that's what we're going to do here. From the client, try to access the server. So we start out by poking around on the machine, and very quickly we can see that there is a mounted share to the server, which is very common if it's a file server or whatever. So we have a mounted drive. We have the user who has apparently access to the server in one way or another. Then we're going to use some tools here. Procdump is from sysinternals. Microsoft released nice tools. So we're going to copy the procdump file over to the share that was mounted. Then we start up and use another sysinternal tool called psexec. We connect to the server, command prompt access, then we're going to run the procdump tool. And what procdump basically does is that we can tell where in memory or from what process we want to dump the memory. So we dump it to a file. And here we have the new file. We copy the file over to our client. Harmful, it's not harmful, maybe for the company in the end. So now we're going to use our beloved tool again. Wait for it. You will see which one it is. Yeah, Mimikatz, again and again. So we're going to use Mimikatz. We will parse the dump file that we just extracted from the other server. So we're on the client, we have extracted memory from the server. Now we're going to parse it and see if we can find any nice information from that machine. And you can see it's the same kind of information that we're after again. We have the Nihu user here somewhere. Further down, I think, yeah. We have the Nihu with the password hash again. There's another interesting user somewhere. We have Aiden, which is Anders admin, with the password hash of that specific user. So when we find this kind of information, since we're already trusted in the domain, we can start querying the domain controller about specifically this user. Oh yeah, there's going to be some misspelling here as well. So we can see here that the user that has been logged in to that server is in the domain admin group, which is a very common scenario. I mean, sometimes it doesn't go this fast. One client to a server, you find domain admin, but very often it really is. So we have the password hash, we copy that one, and then we're going to bring that password hash back to our premises and use our GPU-based password cracker. So that's going to be the next step, because we want to have the clear text password of this one. But I need to say as well, to be able to use this, you could do, there is another technique called passing the hash. So for authentication purpose, we don't need to have the clear text password. We only need to have the password hash. Then we just pass that hash to the system and authenticate with it. But for the sake for the presentation and for the things we're going to do, we will bring it over to us again at SecureLink. So here we have the newly collected password hash. We will run it through our GPU-based password cracker, and this goes really fast. A couple of seconds later, we will have the password. So here we can see, maybe not very clear, but we have the password Acme 2017 exclamation mark. And what needs to be noted here as well, because I'm really fascinated by people and choosing passwords. I really love, I mean, when I do penetration tests, of course, especially internal penetration tests, I think get all the passwords and cracking the password hashes and seeing what people choose for passwords. I think it's really fun. It's a lot of fun to see what they're choosing. And this is very common. It's a very common scenario because Acme, that's basically the company. 2017, that's going to be the year. Exclamation mark. So this is a very common standard formatting of password that we see throughout companies. You can bet on that you find at least 1 to 10 passwords formatted like this. Company name, year, and exclamation mark. And I think exclamation mark specifically because that is the first special character on your keyboard that you choose. So it's very simple. As I said, very fascinating. So now we have the clear text password. So of course now we have domain admin, we have the password of the domain admin, and everybody would say, well, you have the key to the kingdom. We can stop the presentation and go home. It doesn't really matter, does it? Or, I mean, for us as an attacker, I would say there is always better access to get. And that's what we're going to do. There's 2 more steps. No, not that one. Here. So the next step is what we call the DC sync. And what we really do here is, since we have the domain admin user, from our client, we will impersonate a new domain controller on your network. And we will send a request to the domain controller and ask them very nicely to sync all of the password hashes that is stored in the true domain controller. Do you think that would work? I bet it does. Very nice. Found the domain admin. Password Acme 2017. Really bad password for domain admin, but that's how it is sometimes. So we open up a new command prompt. What we need to do here is we need to run this command as the domain admin. So we basically tell we ask the command prompt here to run a new command prompt with the domain admin privileges. So we have embedded those privileges into that command prompt. Here we have it. We start PowerShell. And now we're going to run another nice tool or a PowerShell script called invoke DC sync. And as I said, we impersonate a new domain controller in the network. We send a specific request over the network to the domain controller and ask them to sync, because that's what domain controllers do. And here we have them. Thank you. And here's where I'm sitting there and cracking password and have a look at your passwords. That was a funny one. So as I said here before, we have the domain admin. We could get access to everything that is connected to your domain, basically. But what we want to do, we want to be persistent, because if the domain admin changes his password, yeah, we don't have access anymore, of course. So if you take a look at the first one that I marked up here, the Kerberos, anyone who knows what that account is? If you work in a Windows environment, you need to know what that is. It's the Kerberos ticket granting ticket. So it's basically the user account, or the account that you need to take care and look after, because that is the one that it creates the tickets, the Kerberos ticket for authentication in your Windows environment. So by having this one, we're going to do what we call the golden Willy Wonka ticket. We talked about persistency. So by creating the golden ticket, it actually gives us the possibility, like even if the domain admin changed his password, even if everybody changed your password within your domain, I would be able to create Kerberos authentication tickets within your domain. So to be able to do that, we need some information. And the password hash of the Kerberos TGT user account is one of them. So next step here is basically grab all the information we needed. You can see user account that we're going to create for, domain name, the domain SID, and the Kerberos TGT. You can also see here that we can actually give what group belongings we want to have for this specific ticket. And what needs to be emphasized as well, that the ticket that we create, we can create it that is valid for 10 years. That's a bit awesome. So we have access to your network for 10 years with that ticket. Copy the Kerberos ticket granting ticket, and as well, here I created for the user evil hacker, which is not even within your domain. So I can create the ticket for a user that doesn't even exist, which will put some annoyance when you start reading your logs. Or of course, if I didn't want to create suspiciousness in your network, I would do it for a valid user. But just for the sake of the presentation, I will show you that is possible. So we use Mimikatz again, create our ticket, we load the ticket into our system. And you can see when we list, we have loaded a ticket that we just created. And the next step, we will connect to the domain controller with our ticket that we just forged. And when I run who am I am the evil hacker at your domain controller. So just to wrap this very quickly up again, I'm sorry that I just keep saying. The presentation was about the real world example. I'm not going to say that this happens all the time, but it's extremely common that we do this kind of stuff in corporate environments. But especially, as I said in the beginning, a lot of pen tests that we have is very restricted to certain areas within companies. It could be a specific application, it could be a specific project within your company, but sometimes we get the possibility to do these kinds of attacks. And I would say a lot of the times, this is the outcome. A lot of the times we get a network outlet within the company because there is really no reason to do this more than if you want to analyze what you have externally. But to get the initial access, you can just think about how many computers do you have in your internal network? How many clients do you have? if we would perform a phishing attack, how many persons would click the link? Or if you would have a virus infection or whatever. There's so many ways of get access the initial foothold. The real difference when we get the network outlet is that we don't have the trusted access as a domain access, because if you get that first foothold, you're already domain connected. When we do penetration tests, we're not. But as I said, it's a very common scenario. Yeah, I think the goal was achieved. And we took over the company. Again. Thank you.
Thank you very much.